You guys are going to have 9 questions, which is questions 1 through 9 that we're going to go through today together. And it's basic calculator only. If you want to practice with the red calculator today, you can. Or if you want to use your graphing calculator, that's fine. But it's basic calculator only tomorrow. And then day 2, which we'll review for on Thursday, is the rest of the questions 11 through 19. So for each type of question you're going to see on the test, I have put a bunch of problems. Okay, so what we're going to do for this is we're going to, as a class, and you can choose one person as a representative to pick questions, or you can decide at once, or we can just say whoever yells it out first, that's what we're going to do. But we're going to do one question from each group, okay? And then those solutions I'm going to post. My 8th period is also going to do the same thing. And ideally, you guys are going to pick different questions. So you'll have like a set of questions to practice with. 8th periods will be posted. You can check out those also as extra practice questions in addition to the ones that are already in Polaris. And then you've got a ton of extra ones too if you just want to practice on your own. These came from your textbook, so you could always find these in your textbook under the section and look for them there if you want to, especially the odds. You know, the odds are always in the back of the book, so that's nice. Okay. So let's get started picking questions, going through stuff. Basic calculator only, let's remember. So I need you to pick one problem from this group. Somebody can just yell at a number is fine. And that's one that we're going to do. Which one? 39. Okay. Wasn't sure who said that. All right, 39. Let's do it. So we've got log base 16 of 2, and our instructions are to evaluate it. Okay, so there's a couple different ways to do this. We can either evaluate in our head if we're lucky with the numbers, which this one you can evaluate in your head if you want to. You can figure out 16 to what power would give me 2. You would need a root because it's getting smaller. Or what I would recommend is even the ones you can't do in your head that have weird numbers, we can always use the change of base property. Is going to be really helpful here. The change of base property was we wrote it as 2 logs or natural logs that were divided. Do you remember which way we divide them? Yeah, it's the big number on top, the base on the bottom. And then that's what you could type in your red calculator either with this common log or the natural log. Just make sure you end the parentheses after that first number before you divide. You could do it in a graphing calculator too if that's all you've got in front of you right now. And you're going to get an exact answer of 0.25 or 1/4, which pretty much tells me 16 to the 1/4 power, or the 4th root of 16, gives me 2. So this is one we could have done in our head if we wanted to. Okay, questions on that first one? Evaluating. Okay. Pick a problem from the left side, so 57 through 64, and I'll write a little bigger for you then. What do we want to do? 60. We've got log base rad 3 of 12.5. Can I change a base property again? Definitely weird numbers. I'm not going to be able to do it in my head. Hold on. Yeah. All right, so what's going to go on top when I divide? Log of 12.5 over log of rad 3. There we go. All right. Divided by log of rad. Oops. To 2 decimal places, it's 598. So I'd say 4.60 if I give it 2 decimal places. Okay. All right, pick a number from the right side between 41 and 52. What looks good? 46. Okay, so I've got log base 1/2 of 1/2 to the 5th power. So this is actually one of our log properties we can use here. Actually, you could do it a few different ways. But if you have a log base and an exponent of the same base, what happens? They cancel. So the answer here is just what? That's it. Okay, you could do other things like you could bring the exponent down, you could evaluate it with the 1/2, then you could multiply by the 5, you're going to get the same answer at the end though. Okay, so if you look at that group of problems, you're going to see a lot of the same thing where we have an exponent and a log of the same base and they cancel and we're left with whatever's there. Okay, good. All right, so number 1 on your test is going to be 3 parts, and there are 3 little mini questions like that. Okay, question number 2, you will be graphing a logarithmic equation. You're going to fill out a table, plot the points, and then domain, range, and asymptote. We're going to name. Okay, pick a problem. 75. Sounds good. Okay, so I've got y equals 2 plus log base 2 of 3 minus x. Okay, so to graph a log equation, especially when we don't have a graphing calculator, what we did in the notes is we got the log alone and wrote with exponents, kind of like what we were doing when we were solving our log equations yesterday. So how do I get the log alone first? I got to move some things around in this equation. How do I get the log alone? Subtract 2. Y minus 2 equals log base 2 of 3 minus x. Once your log's alone, WWE, we're going to write with exponents. What's the base going to be? If you know nothing else about logs, you better know how to write it as an exponent, or this test is not going to go well for you. This is important. How do I write this as an exponential equation? What's the base? 2 to what power? Y minus 2. What's alone in the log equation is always your exponent, equals whatever's left. 3 minus x. Okay, so making it exponential is going to make it easier for us to plug numbers into our table, because that's going to help us with our red calculator. The other thing that's an optional step that I would highly recommend doing is getting the x alone. So normally, when we fill out a table, we plug in values for x and get out the y's. We're doing it opposite here. We're going to plug in numbers for y and get out x. So if the x is alone, our life's going to be easier. So I'm going to subtract the 3 over. 2 to the y minus 2 power minus 3 equals negative x. And then how do I get rid of that negative? Divide or multiply by a negative. So I'm actually just going to put that whole left side in parentheses and then a negative in front of it. It doesn't matter what form I write that in. The goal there was just to get the x alone, so it's going to be easier to type in my calculator. All right, so now we're ready to fill out a table. You can use whatever values you want. Typically, again, normally we use x's and we get out y's. We're doing this the opposite way. These are good values to start with, -2 to 2 for your y's. And then if you needed to, you could always extend it one direction or another. Excuse me. Okay, and then this is where we're just going to use our calculator. Decimals are fine here. So I'm going to plug in -2 into that exponent. Be careful with parentheses. You can practice in your calculator if you want to. So 2 to the, in the red calculator, you might want to put an extra parentheses around your exponent just to be safe. So it's going to be -2 minus 2, or you could just type in -4. Okay. And that parentheses, minus 3. And the negative out front will switch the sign. So I get 2.9375. Okay. And then we're going to do the same thing a few more times. So plug in -1. I get 2.875. Plug in 0. 2.75. Plug in 1. 2.5. Plug in 2. I get 2. I'm going to do a few more just because all those numbers were kind of close. I'm going to keep going in that direction though. So I'm going to plug in 3, 4, and 5. If I plug in 3, I get out 1. If I plug in 4, I get out -1. And if I plug in 5, I get out -5. So that gives me a few more points to plot. Okay. All right, so you can hopefully already see what your asymptote's going to be here. Your asymptote is whatever your x values are getting close to. Log graphs always have a vertical asymptote, and you can see the x's are getting really close to 3. So my asymptote is x equals 3. If you don't see that, you can always plug in a few more points until your values start to get really close together. You're also going to be able to find it. It's usually located inside the log there too. Whatever numbers added, subtracted on, that's going to help you get it. Okay. All right. So x equals 3 is my asymptote. I'm going to draw that in because I know it. And then your graph is either always on the left or the right side of that. So let's see. At -2, I'm at about 3. Oh, wait. I got to make sure I plot this in the right way. My x is about 2.9. My y is -2. There we go. My x is 2.8 something. My y is -1. 2.75, I'm at 0. 2.5, I'm at 1. Those are all still pretty close together. 2, I'm at 2. There we go. 1, 3, -1, 4, -5, 5. You just got to be careful when you're plotting those because our table's backwards from what we're used to. But it's going to look something like that. Okay. And then from the picture, if you didn't know it already, you can get the domain and range. The range for these graphs is always all real numbers. That is easy points on this test tomorrow. That answer will never change. The range is always all real numbers. Plus, the domain is either everything to the left of your asymptote or everything to the right of your asymptote. In this case, it's everything on the left. So my domain is going to be -infinity to 3. 3 is a parentheses because it's an asymptote. I'm not allowed to cross that. This one I would say is the more complicated version of what you guys might see on the test. Let's call this problem over preparation. But it's going to be similar steps, right? Get the log alone, write it with exponents, plug in numbers for y, and get out the x's are how you're going to get these points. Any questions on that one? Yes.
When you plug in the calculator, like it's hard to do on the red, like the red calculators. Like I can't plug it in.
So you can just do it in phases in the red calculator. So just order of operations, and you have to kind of know what the order of operations is. So we would do the exponent first. So if I were going to plug -2, my first one, -2 minus 2, I know that's -4. So in the red calculator, I would do 2 to the -4th, maybe get that answer. Then subtract 3 from that. And then this just tells me change the sign, make it opposite. So you can do it in pieces if you don't want to type it in or you don't feel comfortable typing it all at once with that right calculator. I get that for sure. Or you can even do that work like on the margin off to the side of the paper, simplify a couple little things before you type it in to make it a little easier. But like I said, there's a lot happening in this problem. The one you guys see on the test won't have as much stuff in the equation. So it won't be as bad to type in. Okay? Anything else on that one? Okay. All right. The majority of the rest of the problems now are just our solving logarithmic or solving exponential equations. We're not going to have anything with an absolute value, so I'm going to get rid of those. Okay, so pick a problem between 15 and 22. What do we want? 21? All right, so I've got 1/2 log of x minus 2 equals 0. And this log base, if it doesn't have one, what can I put there? 10. Okay, so if I have a log, that's what we did yesterday. First thing I should do is get it alone and then write with exponents. What do I do first? Before that. I have to add the 2 to the other side. Yep. That -2 is not inside the log. If it was, it would be in a parentheses. So we assume it's not in there. Okay, now I can multiply by 2 on both sides, or divide by half, same thing. If I multiply by 2 on both sides, I get 4. Now my log's alone. Now I write with exponents. If I write with exponents, what's my base? 10. What's my power? Equals. What's left? And that's actually my answer, 10 to the 4th. 10,000. This is 1 because it's a common log. You could just plug it back in and make sure it works. Questions on number 3. Okay. Number 4 is a basic exponential equation. What we did on Thursday last week. Pick a number. 32. Okay. I have 3 to the 2x minus 1 equals 2 to the x plus 1. All right, so when we're solving an exponential equation, similar to the one we just did, we want to get the exponent base alone, and then we use logs to solve instead of getting the log alone and then using exponents to solve. They're always opposite. Here, I have 2 exponents, and they're actually already alone, those bases. There's nothing added, subtracted, multiplied, or divided by them, so we're ready to take the log on both sides. Stick with either common log, that's what I'm going to use, or natural log, because those are buttons in our calculator. Once you introduce the log on both sides, what am I allowed to do now? Bring the power down. Okay, that's a log property, so I need the log before I can actually do that. X plus 1 log 2. Now, it looks a little gross, but remember, when you have log and just a number, that's a number. Like, I could type in log 3 in my calculator and get whatever number that's equal to. Same thing with log 2. So this is where we're just going to get rid of one of them, move it to the other side. And you have a choice. You can get rid of log 2 or log 3. I'm going to divide both sides by log 3. And we talked about these ones in class before. It's all products. Things are multiplied on both sides. So you only have to divide it in once because there's one term on each side. If I had 2 separate terms on a side, we'd have to divide it into both terms. On the left, the log 3's are going to cancel, just leaving me with 2x minus 1. On the right, I have an x plus 1, and then log 2 over log 3, that's what now you're going to put in a calculator. Again, make sure you end the parentheses before you divide. And I get about, I'm going to give it 3 decimal places, 0.631. And now you just have, it's a little gross with the decimals, but it's just a linear equation to solve. So I'm going to distribute 0.631x plus 0.631. Then I'm going to move my x terms together. So I'm going to subtract that 0.631x. So 2 minus 0.631 gives me 1.369x minus 1 equals 0.631. Okay. Now I'll add the 1 over. 1.369x equals 1.631. Like I said, kind of gross with the decimals. And then divide last. And I get to 3 decimal places, 1.191. And then you can absolutely plug that back in if you have extra time. Make sure it works. Now that's rounded a little bit, so it might be approximate when you plug it in, but it should be pretty close on either side. And questions on number 4. All right, number 5. We have another logarithmic equation. Pick a number 55 through 58. 56. I have log x squared minus 6x plus 9 equals 0, and this log doesn't have a base, so what can I put there? 10. Okay, so if I have a log equation, I get the log alone. Check. That's done. There's nothing added, subtracted, multiplied, or divided by my log. What's my next step? Right with exponents. How many times have we used that step already today? Like 4 times? Don't forget this step. Please don't forget this step tomorrow's test. Okay. How do I write it with exponents? What's the base? What's the exponent? Equals all that other stuff. And what's anything to the 0 power? 1. I have a quadratic. What should I do to solve my quadratic? Is it equal to 0? So if I subtract 1, I'm going to get an 8. Can you tell me 2 numbers that multiply to 8 and add to -6? -4 minus 2. My answers are 4 and 2. And again, because this one's a common log, pretty easy to plug back in and check if you want with your calculator. Questions on number 5. Okay. Number 6, we have another exponential equation. Pick a number. What looks good? 10? Okay. We have 5 to the x minus 1 equals 1. Now, this problem is not as obvious, but if you look at some of the other ones up there, do you guys see a relationship between all the bases here? Like 2 and 16, 8 and 32, 3 and 243. So these are actually, you can use logs or you don't have to use logs. You can get a common base on both sides and then just compare the exponents here. If you don't remember how to do that though, just use logs like we did in that first exponential equation. But here, I can write 1 as a power of 5. 5 to what power is 1? 0. And if you can do this, if you can get a base to a power equals a base to a power, you can just say, well, the only way that this equation is going to be true is that those powers are equal to each other. So now I can just say x minus 1 equals 0, and therefore x equals 1. So it kind of saves you from having to do that log stuff if you're able to get that same base on both sides. So I think it's worth looking at if you can do that in certain problems, because it can definitely save you some time and it doesn't make it as complicated. Okay, but if you did logs, take the log both sides, bring the exponent down, divide the log over like we practiced. All right, let's try number 7. This is my favorite problem. Pick a number. 3. All right, 1 over 243 to the 3y power times 3 to the negative 15th equals 9 to the 2y. Okay. So it's an exponential equation, solving for an exponent. I have 2 choices. I can either use logs or I can get the same base on both sides. Look at all your bases. 243, 3, 9. I do not need logs to solve this problem. 243, 3, and 9, I can write all as powers of 3. So that's going to be the first thing we do. And if you're not sure what 243 is a power of, you can do a little guess and check with your calculator. Does anybody know what 243 is? 3 to what power? 3 to the 5th. And this is a power to a power. It's an exponent property from Algebra 2. We're multiplying that by the 3y. Okay. Then I have 3 to the negative 15th. So that guy's good. And then 9 is 3 to what power? Squared, and then that's also multiplied by the 2y that's already up there. So my right side is good. I have 3 to the 4y power. That's what we want. We want a base to a power. Stop. Okay. On the left, there's a little more simplifying we need to do. First of all, that stuff in the bottom, I need to move up. I don't want it down there. How do I move something up with an exponent? What exponents will do that? What exponents will flip a fraction? A negative. So that's a 15y down there. If I make it a negative 15y, I move it up to the numerator. Okay. And then I have 3 to the negative 15th. There's only one more thing I have to do. I need to put those bases of 3 together. They are multiplied. What do you do with exponents if you have 2 bases that are multiplied? This is another property. We add them. Negative 15y plus negative 15. If it was divided, what would I do with the exponents to combine them together? Subtract is the other property you might have to use. Okay, so all of this is just exponent rule stuff. And the goal is to get it to look like this. A base to a power equals base to a power. So now the only way that this equation is true is if these powers are equal, because the bases are already equal. So we can just drop those bases and say, all right, negative 15y minus 15 must equal 4y. I don't need logs to solve. And now I'm going to move that 15y over. That'll give me a 19y. And divide, I get negative 15 over 19, which is a little gross if you want to plug it back in and check, but you could. Okay. All of those problems at the top, if you look at those bases, they can all be done in a similar way. So this problem on the test, when you look at it, you're like, whoa, there's a lot going on. Just think to yourself, I need to get a common base. I need to use my exponent properties to simplify as much as possible, and then I can just compare the exponents to get the rest of my answer. But you really got to know your exponent rules for this one. Any questions on number 7? Okay, number 8. with a logarithmic equation again. Pick a number. What looks good? 18. Log base 2 of x plus 1 equals 3. Log, it's alone. Check. What's my next step? Right with exponents. What's my base? 2. What's my exponent? Equals x plus 1. 2 to the third is 8. X is 7. Okay. All right, we just got one more. This is where we have multiple logs in one problem. Again, like we practiced yesterday. Pick a number. 70? Okay. Log base 3 of x plus 1 plus log base 3 of 2x equals log base 3 of 3x plus 1. Okay, so if we have a single log, we want to get it alone, but we don't have a single log here. So that's actually our goal, is try to condense it to get as few of logs as possible in this problem. The 2 logs on the left side are added together. So if I want to condense those, I can change that addition to what? Multiplication. The log base stays the same. So log base 3, and then x plus 1 is going to get multiplied by 2x, and that's all inside the log like that. Okay. And you can simplify it a little bit more. I can distribute my 2x in. So I can make it 2x squared plus 2x. Now there are 2 things that could possibly happen at this point. Either you have just one log in your problem, and then you write with exponents. Or, like this problem, we have logs on both sides. So this is like when we got the exponents with the same base. If we have exponents with the same base, we can compare the exponents. If we have logs with the same base, we can just compare what's inside the parentheses now. We don't need the logs anymore. We can just say the only way this equation's true is if 2x squared plus 2x equals 3x plus 1. And then from there, quadratic, get it equal to 0. This is all just review now. So I'm going to subtract 3x. That'll give me a negative x. Subtract 1, negative 1. This one is factorable. It's not too bad. You could do guess and check a little bit. What 2 numbers multiply to 2x squared? What 2 terms multiply to 2x squared? What's got to be in the front? 2x and x. And then what multiplies to negative 1? It's got to be a positive 1 and a negative 1. So the only thing you really have to figure out is where does the plus go and where does the minus go. You got a 50-50 shot on this one. So I want my inside term to be a negative x. So that means my outside plus my inside need to give me a negative x. So I can put the negative there and the plus there. That'll make that happen. My outside terms would be negative 2x. My inside terms would be 1x. Remember, if you get stuck with the factoring, we've always got quadratic formula in our back pocket, right? So answers are, if I set each of those equal to 0, negative 1/2, and positive 1. These problems where you have multiple logs, we're writing with exponents, where we're condensing and expanding, are where you could get extraneous solutions if we have multiple logs in our problem. So that's what we want to check now, and you should always check your answers, but here it's vital that we check our answers. That when we plug these back in, we're really looking at what's inside the log. Okay, so here, here, and here. We are not allowed to take the log of a negative number or 0. So we want to make sure when I plug those numbers in that all of those, what I put in boxes up the top there, are always positive. If I put negative 1/2 in those boxes, am I going to get positive numbers every time?
It's negative 0.5.
No, like 2 times negative 1/2 is going to give me negative 1 for that middle one, right? So that guy is extraneous for sure. What about 1? Is that one okay? Yeah, okay, so we're not crossing out negative a half because it's a negative number. We're allowed to have negative solutions, but we're not allowed to, when we plug it back in, have a negative inside our log. Okay, so that's what your test is over tomorrow. Plus, you have a bonus question tomorrow. I'm not going to tell you what that is. So I'm going to post our solutions and our video. I'm going to post 8th period solutions, and I'll make sure they pick different problems. So those are good ones to look over tonight. And then you have some extra practice problems in Polaris tonight, too. You can practice with. And then is your last Math XL due tonight, too?
Yeah.
All right, last Math XL due tonight if you haven't finished that. What time do we get out of here today? Anybody remember? Is it right now? I want to get your quizzes back. If I can. Have a minute? Let's see. We get out of here at 14. Oh, I got 10 minutes. All right, you may keep these. You all have the same form of the quiz. So you may compare the multiple choice answers were worth 2 points each. The questions at the bottom were worth 1 point each. Mrs. Benson started grading it for me, but she took 2 points off for all the bottom questions, so I edited it. That's why there's a lot of scratches on there. I gave you more points than she did. Okay? All right, so hang on to these. Use these to study with. Good stuff on here. We want to know what mistakes we made so we don't make them again, right? And then first part of the test tomorrow. Thursday we'll review for the second part. And the second part you can graph calculator for.
Kind of like an extra section.
Yeah. Oh, yeah,
So adding 5, right? 5? Yeah.
Let me know if you have questions on your quiz. Like I said, you
get 7, right? Adding regular math. You get 7, right? 7?
Okay.
Yes.
So,
Did you get 12, right?
should
But apparently with field, so.
expanded this first. So these are the problems where I said our written instructions are expanded.
That was, yeah, that was one of the
And I was like, multiplication. Oh, separate. So it ends up being this number plus. Okay, so 1 half goes up, that's the square root. Yeah.
How'd you do, Addie? Pretty okay. I did not do the okay. I missed, yeah, I just said 2 points were off because I missed up. So you got a 23 out of 32.
Oh, what? X is the right term. That's why.
I got a
So
23 out of
it's the 1
32.
half.
That's not terrible. You said you grade on all the other ones. I don't. I really usually do. No, I don't. I get to
So
Z.
1 half minus 4 gives you negative.
Everything you do is just anything above a D.
So if there was like
I missed it.
X, Y,
If you said the test is coming.
stop here.
No, I don't know. You said it. Oh yeah, this is not. So I can go. I got all this. I understand what I got wrong. Yeah. You just like it was just the time zone. Exactly. She came over here and she's the reason why she's like some of you are so equivalent you like 20 minutes. Like if I had time I would have figured it out. I know, it's so rushed. Exactly. She showed me I was trying to be nice, but she said she was great. And I want to be like, oh, she's rude. I gotta like actually take points off. For real?
What letter does that show you? Where?
That would only be half a B though.
Looks like a 12 or an R.
I think question
It looks maybe like a D. I mean, it looks like a D. More like a D than a.
Actually, I can search later. Oh wait, no, you don't know 12.
We had
Never
to
mind.
get only 4.
That one was literally
Alright.
that one I do not because I'm like,
Very careful with how we write.
mine was in bubbles. I think so. We're Alaskan. My graphic was
But I
Alaskan.
do see
Underneath
it
was a whole. What was the one that stopped? I was stuck.
so that's gonna stay. Alright.
I'm just confused.
Well, I started plugging things in.
Yeah, I forgot how
There's
minus one.
Okay.
I know, if I can figure it out, I'll just plug everything in easier. I'm gonna,
Would it not be -4 to be?
I'm actually not getting that.
Or, oh.
This is not a logarithmic equation, this is an exponential.
I'm not,
The vertical aspect,
Oh,
horizontal
okay.
aspect. So your domain range is actually all of the range.
Yeah, could be. It's a terrible.
Yeah, probably.